Let's start with the 12th question. Plot a graph showing variation of de Broglie wavelength lambda associated with a charged particle of mass m versus 1 by root v, where v is the potential difference through which the particle is accelerated. How does this graph gives us the information regarding the magnitude of the charge of the particle? Okay, we have to draw the graph lambda to 1 by root v versus 1 by root v. Okay, let's draw it and generate the equations. Let us consider a particle of charge q and mass m and speed v and kinetic energy by ke and it accelerated by the potential difference v. Thus we know that kinetic energy equals to qv equals to half mv square. From this v small v velocity will be root 2q by v by m. And the de Broglie wavelength equation is lambda equals to h by mv. From this substituting value of v in this equation we will get lambda equals to h by root 2 mqv. Now we know that the straight line equation of straight line is y equals to mx, where m is the slope of the line. So hence we start the plotting lambda versus 1 by root v graph. So we will have a straight line with the slope s equals to h by root 2 mq. From this q equals to s square by 2m s square. This is the graph has required graph where slope s equals to h by root 2 mq.